So first, a bit of background about myself. My name is Atanas. I'm a software engineer at Schwarz IT, and I work for the IT Solutions Development Department, and I'm part of a team which develops and maintains our CMS for property management, among many other systems. And why am I talking about this topic today? So basically, I was given a task which I finished quicker than expected, and I was crying out for work. And my colleagues gave me a task as a bit of a challenge and maybe as a bit of a joke, as it was me being unaware that it was something that they had attempted to do several years ago and that they failed to do it. And there was a good reason for it. The technology wasn't quite there at the time. And after a lot of hard work, I was actually able to solve it. And why am I giving you this talk today? Well, at the time, to the best of my knowledge, it was only us at Schwarz and a few other companies that had used this technology in this way. And I've seen more adoption in the past 3 months by other companies. I've seen some GitHub repos pop up, but very few or none of them are really talking about it. There are almost no blog posts, no tutorials, etc., etc. So I want to share my findings as I think they're immediately applicable, practical, and beneficial. So just a very quick look at the agenda. We'll cover some basics as I want to make this talk accessible at all levels from juniors to seniors, and we'll see what, in basic terms, what is an API. We'll then see how that applies design first versus code first in terms of API development, and we'll see what is this thing, an API contract, and why API first is so important. And in the end, we'll tie this whole thing neatly into a knot with a demo. So let's get started. If you came here, first of all, for the IPAs, you're in the right place, but the wrong time. So APIs now and IPAs later. Just a little bit of an icebreaker joke. And before we start, I'd like to make another small disclosure. I'll be using the following presenting technique I learned from the Head First books and an ex-colleague of mine to keep your brains focused. So the presentation has more text than usual, and that's intentional because me personally as a viewer, when I'm rewatching presentations, I like to pause and actually read the text to really get into the contents of it. So it's not a bug, it's a feature. And I'll randomly show you pictures of wolf facts and photos throughout the presentation. This is a brain focus technique to give your brains a bit of a breather and then to bring your focus right back into the presentation. So the wolf is a noble creature and it's driven to extinction in many parts of the world. And I personally have done a small donation to the Euronatur German charity as one of its doings is protecting wolves in Europe. When I donate to charities, I don't tend to stick to any just particular one, but in this case, since I'm using wolves in the presentation, I chose that one. So let's get started. First of all, what is an API? An API stands for an application programming interface. And it's a connection between two computers or between two computer programs. It's a type of software interface which offers service to other pieces of software. A document or a standard that describes how to build such a connection or an interface is called an API specification, and a computer or software that meets this standard is said to implement or expose an API. So each time that you access an app on your phone, like Facebook, or check the weather, you're basically using an API. So to explain this better, you can research on your own leisure how an API can be explained with a restaurant example. Basically, the waiters or the messengers will be your APIs, which take your request as a client to the server, which is the kitchen, which will prepare your food. And then the waiters will deliver it back to your table, which is the response, in this case, your food. So now imagine that you're in a team that's building Twitter, and you have a front end and the back end, and they need to talk to each other so that the front end can display the tweets that are stored in the database in the back end, for example. Now you need to build the front end and the back end in parallel, and the connection over them happens over an API. And in the previous slide, we mentioned that a document which describes how to build such a connection is called an API specification or an API contract. You're given such a document and you set off to build the two front end and the back end in parallel. Now, if the two teams adhere to the contract, everything will be good. And when they go live, their APIs will be able to talk to each other. But if intentionally or by mistakes, you break the contract or the API specification, when you go live, some of your APIs will be able to talk to each other while others not, which will result into production bugs. And this is where OpenAPI and contract validation comes in. It's a way that we can enforce and test APIs and API contracts. So in the current situation of increased remote working, having a common simple medium of communication, such as an OpenAPI document, is indispensable in meeting your requirements when building APIs. Things get even more exciting when such a document can serve as a contract, generate clients, servers, and documentation in a plethora of languages, put your developers and clients first, have automatic fail-fast API validation, is cross-platform and language agnostic, can be both machine and human readable in YAML or JSON formats, speeds up development, prototyping, and reduces costs. And to me, all those things sound exciting. Now, when building software, there are several approaches you can take, and let's discuss it as high-level design first versus code-first development. So with the code-first approach, you start with your IDE, typing out some code, and somewhere at the back of your mind, you're thinking that eventually an interface will have to be created to deliver that service. However, the core functionality is, you're focused on the core functionality and not the interface, and that's what's driving the development rather than the other way around. And when the time comes to implement the interface or the API to deliver your service, the core service is mostly done, so it's driving your implementation. And to the user who ultimately used the interface or the API, it might feel like it wasn't developed that well, like an afterthought, like it was tacked on. This is a synchronous flow encountered more traditionally in the traditional waterfall model, and delays at any point will push back the delivery line, and it will be more expensive. Now, in comparison with an API-first approach, instead of starting with the code, you start with designing, planning, testing, mocking your API. The process is aligned with agile software development. It allows the team and any stakeholders, technical and non-technical QAs, to weigh in on the process early and often, before a lot of time and effort has been sunk into the project, and before a lot of cost has been sunk into the project. So once the direction has been solidified, then the contract can serve as a contract that all the teams can begin working towards in parallel. So let's drill down a little bit deeper. Let's talk about API development in terms of design first versus code first. Like any product, the concept of an API starts with identifying an opportunity and a plan to capitalize on that opportunity. From there are two approaches that you can take to develop the API. The design first approach, where you design the API contract first before writing any code. Then the plan is converted to human and machine readable contracts, such as OpenAPI document in YAML or JSON. And then from that document, you build the code. And then there's the code-first approach based on the business plan. You start directly coding the API, and a human or machine-readable documentation can be generated later on, like Swagger documentation or something like that. Now, random wolf fact. So, true love. Once a wolf has found a mate, they tend to stay together for better or worse, through sickness and health, often until death do them part. They have been known to sacrifice themselves for the survival of other wolves. So move over Romeo and Juliet, there's a new couple in town. So there's the advantages and disadvantages with both approaches. And in the end, choosing the right approach boils down to your immediate technological and strategic needs. So first, let's look at some negatives of the code-first approach. Code-first doesn't mean leaving out the design. Rather, it means the design is hidden away in Jira tickets, Confluence pages, documents, napkins even, and potentially lost to history forever. This can lead to some potential problems. You can have frustrated users. The wrong API can be built if you're not adhering to the specification, and missed opportunities. If the documentation is available, other teams might not discover your API and build the same thing over again, resulting in duplicated effort. Now, let's look at some of the benefits and good use cases for code-first approach. So when delivery speed matters, if delivery speed is one of your important success factors, then coding straight away is obviously the better approach. And if you're developing a small internal API, then again, something that's going to be used only by your team or by your organization, then code first is the ideal approach for you. Now, just pardon me for a sip of water. Right. Now let's look at some negatives of the design first approach as well. It's hard work. To be honest, it takes a lot of time and deliberation for any team to move to design first. And also it takes commitment. Companies must be intentional no matter their size. The shift to design first doesn't happen on its own. Now let's concentrate on the benefits of the design first approach, which far outweigh any challenges. You get product-driven APIs where team can include managers, QAs, and other technical people early and often on the project. Teams can work in parallel. You get shorter feedback loops, and you can view your contract as a source of truth. And if you're delivering mission-critical APIs, if your clients are developers, developer experience will matter. Random wolf fact. It's all in the howl. So wolves do howl at night. And these soulful calls have nothing to do with the moon, like most people think. Their penetrating, hauntingly beautiful howl is a primary communication tool, both between lone wolves and their pack, as well as between packs. So we can already see that design first or API first is the better approach. But why? In a world where speed to markets hold premium, why would you spend valuable building time to focus on the API first? Is it worth it? There are several benefits for choosing the approach that far outweigh delaying your time to market. So you'll get earlier validation, you'll get a clear abstraction layer, you'll decouple dependencies, and you ensure quality, predictability, and stability to withstand especially other developers. A couple of real-world examples. So Twilio is an API-first cloud platform which is tailor-made to support their clients. Their APIs is their products. And speaking from personal experience at the BBC, building a new breaking news app in time for elections with a cross team of 4 teams in 3 different locations, our main channel of communication was an API contract, and without it, we wouldn't have made it in time. And again, speaking from personal experience at Schwarz IT, we use spec-first API development and have seen some great benefits, including reduced development times, tighter feedback loops, and a better API design overall. All of our backend services currently have accompanying spec projects. Currently, most of them are interfaces, but we're slowly moving them to OpenAPI specs, and we intend to use it for any new projects from the start. Now, your API is your contract. And what is this API contract thing? So it's a shared articulation of what an API does, both in machine and human readable. It's basically what your service is, what you're offering. It uses tools such as OpenAPI to describe the requests and responses of your API and functionality offer all over your endpoints that that people can use. It's something that both providers and consumers agree upon, and then they build, develop, integrate, normally for an agreed upon price. And an API contract helps mitigate change, or at least communicates it. So if you provide an OpenAPI spec ahead of each new version release, it will give your developers or your clients a needed time and certainty so that they can review it and agree if they want to commit to it or if they want to change something. So this sounds great and all, but there is normally no way to enforce a contract. So people might keep it, but then they might not keep it. And this can have some monstrous consequences. If only there was a way and relevant tools to achieve this, and there is. So enter contracts first, development, and contract testing and validation. So what is this contract first thing? Contract first development is about making your intent clear across all the team members and external teams. By using a tool like OpenAPI, you can define your programming API clearly at the very beginning. And you also update the contract before you make any change so that everyone can review it and agree to it. So what is this contract testing thing then? So this is the way that we enforce and validate our contracts and our API specifications. When compared to end-to-end testing, for example, the approaches in contract testing enables you to create consistent curves in your pipeline, speed and complexity effort that look more like the curves in the diagram below, and you still maintain many of the safety guarantees of end-to-end tests as well. So how do I convince you? Well, the main thing that any organization cares about when it comes to software development, it's normally cost. And when building a product, your time is probably the biggest cost to an organization. So there will be an initial overhead when you need to move to API first, and you need to integrate it in your pipeline. But using contract tests in conjunction with or as a replacement for traditional end-to-end tests will be cheaper in the long run. And that happens by several reasons. Basically, contract tests help provide very fast feedback loops. They clearly identify where the problem is when something fails, and they ensure that only the parts of the API that will get built, that will get used, get built. Also, they can save compute time and resources. Tooling. So let's see how do we achieve all of that. We're going to need the right tools for the job. And the first tool that we need is an OpenAPI spec. So it defines a standard description format and a language agnostic interface to REST APIs. This shows both humans and computers how to discover and understand the capabilities of your service. Basically, what are you offering? What are your endpoints? What are the parameters? What authentication methods do you have? Contract information, license, terms of use, and can be written both in YAML or JSON. Here is an example of the anatomy of an OpenAPI spec. Now, I'm using an example of an online pet store, a very basic CRUD application, and I've highlighted a few pieces of interest. So there you can see some path getting defined, some methods, some parameters, some responses. And the next really cool bit is the schema. So the schema actually allows you to model an object. So let's say that you have an object for a pet, and a pet will have an ID, which could be of type integer, and it can have a name, which is of type string. So you can model that and then reference it in your API spec. This helps you to abide by the dry rule. So do not repeat yourself. You don't have to rewrite the same object over and over again. You just reference it from the schema. So I think that's pretty cool. Now, the next tool that you need is Swagger. Swagger is a set of open source tools built around an OpenAPI specification. And once you have an OpenAPI spec document, you can combine it with Swagger and you can use it to generate a stub. And then the only thing you'll need is to basically write some glue code or some, some logic code, and your API will be ready to go. You can generate clients in over like 40 languages. You get interactive documentation that you can try it out in the browser, like on the screenshot right there. And you can use the spec for testing, automated tests even, and documentation as well. So what about documentation? So do any of these sound familiar? Code first, documents later, or we'll write the docs when we have time. Almost definitely for sure, maybe. So I'm personally guilty of both of these, and I've done it in the past. The next tool that you need is an OpenAPI generator. So this tool is something that you can give it an OpenAPI spec document, and you can use it to generate for you API clients, server stubs, documentation, configuration, etc., etc. This is basically what Swagger, the tools of Swagger use underneath when they generate something for you. Now, there are several different generators floating around. I think Swagger have one of their own, which is now currently owned by SmartBear. I think OpenAPI have one of their own. I think there are a couple of others floating around. But in the demo, I've used the one from OpenAPI themselves. So that's a pretty solid generator. Now, here is a really important bit of kit. So after spending quite a bit of time researching how I can do request and response validation for our existing APIs, without having to rewrite all the tests, write a whole new suite of tests, or write a small project or like a small library to do all the work for me, I found the answer. And Atlassian have done it. So Atlassian have built a request validator Java library for validating HTTP requests and responses against an OpenAPI spec document. It has several modules and different frameworks, and I'm using one of them in the demo. I'm using the Swagger request validator with the rest assured module. So basically it allows integration with the rest assured testing library. Now, when I was using it, and to the best of my knowledge, the OpenAPI REST Atlassian request validator was free. I think it's under the Apache license, but you can check out their repo and make sure. Just pardon me for another sip of water. Pardon me. Next, we need some tools for validating the front end. And here's a couple of OpenAPI validators for Express.js. They automatically validate API requests and responses based on an OpenAPI spec. Oops, sorry. So these libraries integrate with an existing API application. You simply install the validator on your app. You point it to an OpenAPI spec file and define and implements the routes any way you want. So this will validate both, it can validate requests both coming into your frontend as well as requests going out of your frontend, for example, to the backend. So again, pretty powerful stuff. Now, all the usual suspects, I'm using all of the following just for the demo. So we've got Java, Spring Boot, JavaScript, TypeScript, Angular, MongoDB, Docker, etc., etc. Random wolf fact. So the wolf represents strength, loyalty, family ties, caring, expresses freedom and fortitude. And the Japanese word for wolf, okami, means great god. So I think a pretty cool animal overall. Demo. Now, due to the format of this conference, we will not have time for me to do the live coding demo, but I've recorded it for you on YouTube, and you can access it through these links or to these barcodes. You can scan them right now. It's in 2 parts, so it conforms to the YouTube standards about time limits. And I've also added chapters to it, so you can scroll through it or just see the things that are interesting to you. And I'll just give you brief descriptions while you're copying the links or something. So in the demo, basically what I do is I get an OpenAPI spec file, and I use it to generate the backend in Java and Spring Boot. Then I use it to generate the frontend with Angular and JavaScript. Then I use Atlassian's validator to attest to the backend, which validates the API. Then I use Express OpenAPI validate to attest to the frontend and validate the frontend API. And then I demonstrate how these tests fail if you breach the contract. So either if you make changes to the spec and then you don't make changes to the code, or if you make changes to the code intentionally or by mistake, the test should still fail and tell you, oh, no, you need to change something or you need to talk to someone. So I hope that you enjoy the demo and that you see it and that you find it useful. I'd like to leave you with some closing thoughts. I'd like to leave you with the lyrics from the song Everything Counts by Depeche Mode. The handshake seals the contract. From the contract, there is no turning back. The holiday was fun packed. The contract still intact. So keep your contracts intact, people. Now, a few slides of references. These are all the things that I use for the demo and for the presentation. You can check them out when the presentation is available. And I'll be available for questions. But first, let me just start with an icebreaker question. Well, I've been asked before if you can use OpenAPI for GraphQL, and the short answer is no. So GraphQL breaks REST standards, and unfortunately, as of 2021, there is no standard way to show GraphQL endpoint or link a GraphQL UI to a Swagger UI. GraphQL APIs are usually documented through their own facilities, such as GraphQL Playground or something like that. But because GraphQL and REST are competing with each other, so GraphQL vendors, they want developers not to use REST, but rather use GraphQL or one or the other. I'm hoping that in the future, the advantages in this much of both will be better understood, and there will be more balanced view of when to use one or the other, depending on your use cases. But just in case, here are a couple of translators that you can use to translate an OpenAPI spec to a GraphQL document or spec. I haven't tried these. I haven't had to try them yet. So you can check them out, or maybe you can even find better ones. So now I'm pretty much yours for questions, if there are any.
Thank you, Atanas. A quick question from my side. Do
Yeah.
you think OpenAPI can be used for real-time validation? What's your view on that?
You can. So I've tried it out with the Atlassian library as well. It, for example, I think I tried it with the REST template module. You can use it. It's a bit trickier to, I think, to set up. You have actually levels of configuration where you can fine tune it. But if you're using it for an existing project, it might be a bit harder because you might get a lot of false positive, or it might even try to validate something like requests for downloading like CSS files or other things. And it might need a bit more hard tuning. If you're starting from scratch, I think it might be easier to use it just both real time and just for tests.
Okay, so far we don't have any question from the comment section. So one more from my side as we have the time.
Sure. Yeah.
What about alternatives? Can you think of any?
So yeah, there are. I certainly heard a few things going around. I personally haven't tried them, but there is, I think, a tool called Pact, I think is one of them. And I've also heard about something called Stoplight, I think. Again, I haven't had time to research and try them out, but I think there will be probably even more popping up, as I think this way of working is gaining popularity. So like OpenAPI and Swagger aren't really innovative, but using them to validate contracts and API contracts and API specification, I think that's the innovative bit of my presentation. That's kind of the thing that I wanted to demonstrate.
Okay, so many thanks from our side for your talk. It was really interesting to hear. And wish you a nice day. We'll be happy to have you back next year.
Thank you as well. I hope that people find it useful and start using it. Thank you again for having me. Pleasure.
Thank you. Bye-bye.
Bye-bye.